Hey everyone, this is Cses and welcome to my channel Codesk. We are here to solve another interesting and super problem from CSS problem set, collecting numbers part 2. This is part 2. Part 1 I have already made the video. So it is highly recommended to watch the first part because both are connected. They are connected very much. So it is advisable to watch the first part. You can get the link from the right corner or from the description. So it is advisable to watch that first and then only proceed further. Having said that, let's move ahead and solve this. So we have the same example which we had in the collecting numbers, and if you have watched that video then you know how we reach to the answer to this problem, and that is we require three passes to do it. 1, 2, 3. Now before swapping comes, I want to tell you that we are not going to rewrite the location, as you may think that after swapping we rewrite the location. That is not what we're gonna do. Instead, we gonna either add or subtract from these passes. Either we gonna subtract or uh, increase from these passes, and that is so because we will see in just few minutes that after swapping it is going to affect only some part of the array, not the whole part of the array. So why to waste and rewrite the memory and exceed the time when it can be logically think that it is going to affect only some part of the array. Okay, so we require three swaps. So first swap is at position number 2 and 3. So this is at 1, 2, 3, 4, 5. These are the numbers present at these locations. So we're going to swap the numbers which are present at 2 and 3. After swapping, these would be the numbers, and 1, 2, 3, 4, 5. But instead of doing the swaps on the number, we can do the swapping on their location because it is one and the same thing. So let's try to do it on the location. So 2 would go there and 3 would go there. So it is one and the same thing. You can see also 4 is 1. Yeah. And again there is no point of checking for 4, 5, right, because we haven't touched them. But still I'm telling you 4 is at 1. 1 is now at 2, so 1 is now at 2, correct. 2 is at 3, 2 is at 3, and all other remains the same. So even though these numbers won't be affected, right, so they remains the same. But you would be wondering why I'm not counting number 3 also, right, because that was also unaffected. But if you see the number at position 2 is 1, so a number at position 3 is 2. Now if you think logically, then this new numbers, now I should call the new numbers at these location, is gonna affect its nearby value. So 1 can affect its previous, so there is no previous value, right, 0, so 0 is not there, so it can affect its previous or its next value. So it is going to affect 1 and 2, right, the numbers 1 and 2, and the number at 3 can affect its previous value 1 and 2 and its next value 2 and 3. But also if you see, there is no point of writing it twice. So we would need a data structure which supports only unique values, not the duplicate values. So you can go for maps, sets, whichever you feel good, you can go for. Okay, so here's these new numbers which we need to check, And what we need to check? We need to check whether these new numbers, numbers at these location are contributing to the passes or not. So for doing that, here it clearly, we will go back, that means in the original one, and we will check from here whether what was the condition before their swapping. So before their swapping, what was their contribution, and why we are checking that? We are checking that because before swapping we will see if they are contributing to the passes. If they are contributing to the passes, then after swapping they may not contribute to the pass, right? They may or may not. So that's why we will go and check before swapping what's their condition. So okay, let's check for before swapping. So the bigger number 2 lies before 1, right? Lies before 1. Bigger number 2 lies before 1. The smaller number lies ahead. So that means this is the breakaway point. This is causing the contribution. So what we're gonna do? We're gonna remove the pass. Now we are left with 2 pass. Why I have removed it? Because they were contributing to the passes. Now after swapping, we will see now whether they are contributing or not. If it may not contribute now, we don't need to add the pass. So that's why we will see after swapping. Don't mind my handwriting. So after swapping we will see. So number 1, the bigger number is ahead of the smaller number, so they are not contributing the passes. So we are left with the 2 passes. So I can happily say that they don't contribute to any passes. So it was good that you have removed it earlier, right? We have removed it earlier because now they are not contributing to the passes. Now we need to check for 2 and 3. So let's go ahead and check for these numbers. So number 2 is at position 2 and number 3 is very far, so it is not contributing to the passes. So let's see after swapping what happens to them. So 2 is at 3 and number 3 is very far also, it is 5, so it is also not contributing to the passes. So in short, we have total 2 passes for this. So this would be our answer for this. So what we did, we checked before swapping what was their condition, then we changed their location, their position, swapped their position, and now checked what is now their contribution after swapping, and we removed or increased from the answer. So let's move ahead. Okay, so we are continuing the example. So 1 2 3 4 5, and these are after the first swap has been done. We know it requires 2 passes. Now we need to do for the swapping 1 and numbers at position 1 and 5. But before swapping, we need to look what is their contribution before swapping. So the numbers which are present at 1 is 4, right? So we need to look for its previous and the next. So we look for 3 and 4, and it's after 4 and 5. And the numbers which are present, and the number which is present at position 5 is 3. So we need to look for its previous, which is 2 and 3, and it's afterward 3 and 4. But we are not gonna check for that because it is one and the same thing. So we need to check for whether what is their contribution. So at 2 and 3. So 3, 2 and 3, right? First this one. So 2 and 3. Okay, so 2 is at position 3 and 3, which is a bigger number, is very far, no need to worry. It is not contributing to any passes. Then for 3 and 4, for this, the smaller number is at position 1 and the bigger number is very far. So this is contributing to a pass. So at this time, we will remove the pass. Okay. And now we are look for 4 and 5. So 4 and 5, 4 is at 1 and 5 is very far, no need to worry. So since this pair was contributing to the pass, so we removed it, and now we will perform swapping. So let's see what's the new scenario after swapping. It should be very clear that why we are undoing the change. We are undoing the change because we don't know after swapping it may or may not contribute to a pass. So let's do the swapping. 1 and 5 are swapped. Then we are going to look for at position 1 we are look for its previous value. So at position 1 we have 3, so its previous value is 2, 3, and its forward value is 3 and 4, its next value. Similarly for 5 we have 4 and 5 and its next value 3 and 4, but we know 3 and 4 it is one and the same thing, no need to write it twice. So now we have these. Now let's check for these. So 2 and 3, is it contributing to a pass? Let's see. 2 and 3. So 2 is at 3 and the bigger number is before the smaller number. So this is going to contribute to the pass. So we will add 1 to the pass. Now we look for 3 and 4. So 3 is at position 1 and the bigger number is very far, no need to worry. And for 4 and 5, so the smaller number is the bigger number is before the smaller number, right? 5 is at position number 4 and the smaller number is ahead of the bigger number. So this is going to contribute to a pass, so we will add. So for this we have total 3. Now we need to do for the last swapping. So let's do that. So for the last swap, which is at 2 and position 2 and 3, and we know that for this for this scenario we required 3 passes, and let's see the condition of before swapping. So the numbers which gonna affect is at position 2 we have 1, so before 1 there is no number, so 1 and next number 2, and at position 3 we have 2, so it's before number 1 and 2 which we are not gonna write, and at position 3 we have 2, so we will write the next number 2 and 3. So what's the condition? So 1 and 2, so 2 is ahead of the smaller number, no need to worry, and 2 and 3 numbers 2 and 3, so 2 is at position number 3 and 3 is very far, no need to worry. So there was no changes. Now let's do the swapping and let's see what's the new scenario. So we do the swapping and we know the numbers which are going to affect are nearby numbers, which are 1, 2 and 2 and 3. So 1 is at position 3 and this bigger number is before the smaller number, right? It is at position 2 and this is at position number 3. So of course we will need a pass, so we add a pass, and then we will check for number 2 and 3. So number 2 is at position 2 and the bigger number is far, no need to add the pass, and that's done. So we require 4 passes for this. Okay, so let's just summarize all the steps which we are doing. So firstly we filled the numbers, that means we filled the numbers in the array or vector, and then we filled the location of their numbers, which is the required. Why it is required? Because we need to count the total passes required. So this is all the same which we were doing in the collecting numbers part 1 problem. Now we will do is the next is we will create a set or map of the numbers to be checked. So these are nothing, just to check the numbers which are being affected when the swapping is done. So this is that set or map in a data structure which can hold unique values. Then before swapping we will going to check if it is contributing to the pass, and if it is contributing to the pass, then we should undo the pass. We should subtract it from the total passes, and afterwards we will swap. And after swapping, we are basically swapping the numbers, and also we are swapping the new locations now of theirs. And then after swapping we will check if it is not contributing to the pass. If it is so, then we will increase the pass, and finally we will display. So let's write the code of this, and we will have a better understanding of this. Okay, so before moving ahead, I want to give you a little warning. So if you are planning that we can do this collecting number as previously done in the problem, so it is going to give you time limit exceed error on the second test cases, and probably many of would be getting this, and you would have thought that okay, so we are going to create a array, and then we will create a function for collecting number which was same as the previous, and we would create a location vector which is going to give the locations of the number. So we will swap the positions which are given here, and then we will create a new location, and we are going to pass this to a collecting number function, and it will give you the output. And on each iteration we are going to perform this on the each swaps required, but that is going to give you time limit exceed error. And the reason because it's the same, you are reiterating the things which are not required. So it will be more clear when I'm going to explain this in detail. But yes, we are unnecessary creating the location, we are unnecessary running the loop to create the location. But if we think it in a logical manner, then there is no need of rewriting this location again and again. So let's head over and study this more. Okay, so here I'm on VS Code, and let's get the input. So we require n and m, the array size and the number of operation, and the next line n integers contains the numbers in the array. Okay, so here I'm on VS Code, and let's get the input. So we require n and m, the array size and the number of operation, and the next line n integers contains the numbers in the array. Okay, so constraint is good for the integer data type. So let's just declare the variables and initialize it with 0. So n k a comma p is equal to 0. So n is the number of size of the array, and the k is the swapping operations, number of operation we need to perform, and a and b are the positions or the locations of the numbers which needs to be swapped. Okay, so first of all we will get the number and the number of swappings required, and now let's create a vector or integer type, and let's define it a numbers. It is basically going to store our numbers. Let's make it n plus 1. Since 0, there is no such number present at location 0, so that's why we have increased the number array to one more. Now we will have this for the location or position, whatever you want to call. I call it this location, and then we can create here set map. So let's create map, because map I have made the video also of it. You can check the maps video if you have any issue. Let's take the map. It has key and value pair. So here basically the key or value won't be have any logical meaning. It is key and value. Basically the key may contains the number which is present at previous location, and that is -1, and the value would be the number present at the next value. So let's make it num pairs. Alright, so let's get the input. And we will have the input in numbers vector. You see here we are not starting from 0, we are starting from 1, and at the same time I will fill the location of these number as well. And yes, that's done. Now before swapping we need to count the total passes required. So let's count the total passes required. And if you have any issue in understanding of all these lines which I am writing, I have clearly explained in my first video. You can go and check that, the collecting numbers part 1 video. So if this is the case, then increase the pass, and I don't think so we have created pass variable. So let's define it here only. So we have the pass, and we need to increase the pass by 1 also. So okay, so till now all these lines are just from collecting numbers part 1 problem. You go and watch that, you will have a better understanding there. Now I will run the while loop for the swapping. So first we will get two numbers, that is the positions which needs to be swapped, so A and B. And what we need to do now is we need to put the numbers nearby numbers which are going to be affected after swapping. So we are gonna put the numbers into this. So we will put the numbers, but we will check for boundary condition. Okay, so if numbers at position A, and first we will check numbers at position A -1 is greater than equal to 1, meaning we are checking the left side. If it is greater than equal to 1, that means you can insert in the map. So what we will insert? We will insert numbers at position A -1 and its next value, which would be this only, right? This, and now we will check for the other boundary condition, which is at right. So right condition would be like this: if num plus 1 is less than the number, less than the largest number. If that's the case, then you can insert what we can insert: numpair dot insert. We will insert number at a comma numbers at a plus 1, its next value, right? If we are checking for, let's say, 4, so we will check for 4 and its next value 5. So so what happened is, okay, I haven't put comma here. Okay, all right, I think it is clear. Now this same performance we need to do, the same thing we need to do for B. So if the second way, we need to check for here boundary condition. If this is the case, so we will happily replace this to B, and if here B is, so B and B, if it is contributing to the passes. So we'll check before swapping if it is contributing to the passes. So we will go into our array, into our map which we have just created, and we will check id is not equal to numpairs dot end id plus plus. So we are traversing in the map and we are checking, what we are checking, if location of the first we do this to catch hold of the first key value, you can say. If so, I am just writing the same logic here what I wrote here only, so, but in a similar fashion. So if is greater than if this is the case, then we will decrement the pass. We will decrement the pass. So if swap, so I can call this function and we will swap the numbers, and also we need to make changes in the location. So that we can do by saying numbers at a is now becomes this location, and location at number B would become P. So this would happen, and after this after swapping, so firstly we need to check if it is contributing to the pass. So for that I can just copy these lines, and here only if this is the case, then we will increase the Here we undo the change, so it was contributing to the passes, so we decrement the pass, and here basically we are after swapping we are checking if it is contributing to the pass, then increment the pass. Then we can display pass, we'll leave a new line, and also before going ahead I need to clear the map. Okay, let's try to submit this. Alright, so it has accepted, and if you have still any queries you can ask in the comment. And it was not that much complicated. If you think it is that much complicated, we simply created first the location, and we collected all the number of passes which we required. Then we did the boundary condition for our map, so that if it is 1 then it should not put 0 in it, right, because we are subtracting here. So that's why we have, and also we are incrementing, so if it should not cross the maximum value. So that's why this is the boundary condition to just put in the map, and this is basically undoing the operation. If this has caused these number pairs has caused the increment or contributed in the pass, so we should undo that, we should subtract the passes. Then after swapping we need to again check for the number pairs whether they are contributing to the pass or not. So you just try to run this on your own and it will be cleared even more. Okay, so thank you for watching.